Hi, welcome to Standard Operating Procedure, the Cafe Tele live broadcast, where we show you tips and techniques, tools, and tactics for helping you love a career in telecoms. Today, we're going to continue from last week's live broadcast to help you understand modeling. So modeling is a really standard thing that we do in telecoms to understand how a given change or a given proposal works out. So I'm a really practical type of guy. I've set up a very practical example. Imagine that you were tasked to determine what's the right approach to get a new lease line. Imagine it's a 10 gigabit per second lease line. And your choice was you could either get it as a 10-year one-time lease, or you could do it as a bunch of much shorter leases and just do them back to back for the whole 10-year interval. So I think the way I teed this up was compare the cost of a short-term versus a long-term lease. Okay, so that's what we're going to do today. If you have any questions, put them into chat. I'll try and make sure I can see chat throughout the whole live broadcast so I can get to your questions immediately. And if you want, go ahead and open up your own version of Excel so that you can follow along. And then after this broadcast, I'll make the workbook that we're working on. I'll make that available for you to download so you can see exactly what I'm doing. I try to remember to zoom in or to magnify the spreadsheet that I'm working with, the workbook I'm working with. Sometimes I forget though. So let's share the screen, and I'm gonna have to share. Let's see, make sure there's nothing else here I don't want to share. I'm gonna close that, and I'll close that. So I think the rest of this is all copacetic. And I'm going to share my whole screen. It's a big screen, but with Excel, sometimes when you pop up a dialog box in Excel, like the format box or the name manager, that's technically a new window. And if I only share the Excel application window, any box that pops up, that Excel pops up, is a new window and you cannot see it. So the only way to avoid that is either not pop up any dialogues, which is sometimes hard to avoid, or I share my whole screen. So over here you can see the chat. Mostly it's all Excel now, so that shouldn't be a problem. So what we're looking at here, this is the workbook that we worked on last week. I hope you recognize it. We were laying out just the basics of a model that is time-based. So you can see here in this row, there's all the dates, right? And we just did a short sample of dates. And I showed you techniques for using a default value. So here's the default start date was last week, 21 January. And here's a date you can type in. So you can see right now, this was the hard code. Here's the date that adjusts. So you can see my default once again is 21 January. If I take away my manual entry, it goes to 21 January. So this is a way you can build in a default start date, plus give yourself the very easy option of changing it. So if I say, how about 31 March? And now you can see it's changed. So that's kind of what we covered last week. We're going to pick up right from there this week. And I've already copied part of that just to make it simple. And in the notes here, I've kind of teed it up, said, look, we're going to compare the price of a long-term lease versus many short-term leases back to back. So that would mean for a 10-year cycle, one long-term lease of 10 years, total term is 10 years, or a bunch of short-term leases that as soon as one lease ends, the next one starts, but we're going to make that variable so that you can try out different, a 12-month, a 18-month, a 24-month lease, because different service providers will give you these options. So your model needs to have these options built in so you can kind of experiment with whatever options that your service providers offer you. Okay, next, the term is in months. And we also need to know what the starting MRC, that's monthly recurring cost, or that's the initial rate. We're going to assume that for the long-term lease, whatever the starting rate is, it's the same every month for the whole 10 years, okay? And for the short-term leases, I've already said it could be negotiable, so it's going to make that a variable in the model. And we need to learn how to compare the price of these two solutions. So let's get going. Sam, I see your note. Thanks. Appreciate your input. Let's get started here. So really this part up here, I just copied that from last week so that, again, I could put in, let's say I put in February 20th. And again, my model changes immediately. Now, I said this was going to be a 10-year model. So we need to extend this out. We just do that right here. I think that was out around here someplace. Let's see what we got. So that's a little too long. No, that's just about right. There's February. 10 years is 120 months. Huh. When did I start? I got to check this again. 21 February, so I should be going to February of 31. Well, of course. So let's do that. There we go, February of 31. That's actually 10 years and 1 month. So, and another thing is I navigate. Keyboard shortcuts are a terrific way to save time. So I use keyboard shortcuts. If you, on Windows, it's Control and the right arrow. It'll go, as long as the data is contiguous, it'll go to the last cell having data. So if I do Control right arrow, there's the last cell. So I want to come out here all the time. So doing this just makes it easier to get to the last bit of data. If you do this a couple times, you'll see what I mean. So, and I'm going to move my note out of the way. So we're going to start with the long-term model because that's really simple. And I already, of course, I practiced this just so that I, could save time when we're doing it. I'm going to paste this out here. Okay, so for the long-term lease, the monthly recurring cost, so let's just set that up. What did I call that? Long-term lease, well, of course. So I'm going to paste that there. And I'm not going to name all these variables. It's just for this. But I'm going to say, let's call that, normally I would. So I'm going to say it's $100 a month for this bandwidth. It's just to make it simple to understand. And that's going to be here, right? And I'm going to use another shortcut to make it function F4. It makes it an absolute reference. So it puts those dollar signs around it, okay? Okay, so it's $100 a month, and that's for the entire term. Control R fills right. And that's really essentially it for the long-term lease. Probably next week, I don't know if we'll have time today, we'll come back and add something to this. So I'm going to do this. I'm going to say, so here's your subtotal. And we got too much space there. Let's do this. Add a girl. With my subtotal, I'm going to think it's sum. And let's just add this all up. Okay. Now there's only the monthly recurring cost here, but probably I'll come back and show what if there's a one-time setup fee for the lease, or maybe there's an annual maintenance charge or something silly like that. In this example, that probably doesn't apply, but in many models that you build, you will have one-time costs. And I also want to control one is the format dialog box. I want to subtotal that. So now I'm going to, there it is. Okay, so the next step, I'm going to hold off on that. Next, let's start on the short-term lease. And oh yeah, I also wanted to copy this. Just a bit of a divider. So I can easily see the difference between the long-term and the short-term parts of the model. And I'm just going to make that standard color. So let's copy our logo here. Excuse me, our headers. And I left these blank for now. So the monthly recurring cost on the short term, and let's say just arbitrarily, we start out with $120. It's a shorter term lease. Of course, you'll see different. I'm just making this up for the purposes of this lesson. But same thing is we're going to equals this, right? And I'm going to function F4 to make that an absolute reference. And again, I can Command Shift right. This one should have been extended one more. Probably I should have put the X's out here. If you're going to be lazy, you need to be lazy in a good way. So now we're in the short term, the monthly recurring cost. I filled it all the way out and I shouldn't have. So here's what it looks like for just the first few months. Now it's a short term. Let's assume it was just a 1 year, a 12-month lease, right? So that would be correct out to here, right? What happens here? What happens in the 13th month? I need to sign a new lease, and probably that will be at a different monthly recurring cost, because leased rates are kind of like Moore's law in computer chips. It's continually going down. You know, if I'm paying $120 for 10 gigabits per second this month, maybe in a year it'll be down to $115. Dollars isn't important. I'm just saying it goes down over time. So we need to build that in. And there's two ways we're going to do that, because we're going to repeat this throughout the 10-year term. I'm going to have a bunch of leases, and I don't want to have to enter them manually every time. So we are going to assume that each lease is the same duration. I can't think of a way to model variable duration. You know, one's 12 months, the next one would be 18 months, maybe the third one was 24 months. That's too difficult. And I think most of the time it's a safe assumption that every lease will be the same duration. So we're going to, right here, I've said it's 12 months, but well, let's go forward with that. Let me check my notes here. Yeah. So what we could do, it's going to cycle every 12 months, right? So anytime you want to cycle something, that's the modulus operator. Modulus is basically the remainder when you divide two numbers, right? So what we're going to do is we're going to divide 10 years, 120 months, we're going to divide it by 12, and that's the modulus operator. So let's just do that. Modulus, and here's the formula, mod, and it's the number and then the divisor. Well, here's the number up here. Remember, it's the month number from 0 to 120, 119, right? So we can divide that by 12. So we'll divide this by 12, and you'll see it always shows the remainder, right? So 3 divided by 12, it's just remainder 3, 4, etc., until you get to an even multiple of 12, and it's 0. So using the modulus operator, you can see that we can automatically detect when the lease has to be renewed. Automatically detect when the lease renews, right? And so I've hard-coded that 12, and that's a bad practice. You should never hard-code a naked number. So let's do this. Term. And I'm going to name that one term. And the term, ooh, bad form. Oh yeah, I forgot that. So we're going to call it term. Having trouble typing today. Term 2. We'll call it term 2 because I got term on the practice sheet. So I got to reuse this. And let's say the term is 12 months. So now the term is 12 months. So instead of embedding that 12, I'm going to embed term 2. Or I could do my function F3. That's the shortcut to get your named ranges. So there's my term 2. So term 2, and now didn't have happened. What did I do wrong there? It adds term 2. My mistake. So now out here at the 13th month, it starts over at 0. This is exactly what you want. Every time you get to the end of the term of the lease, you have to do a new lease. So let's check this out. That's for 12. What if I what if I wanted 18-month leases, right? Well, come back to my term. Say, instead of 12-month leases, let's try an 18-month lease. Same thing. It works. Every time we get to the end of the 18th month, it starts over the cycle. So I know I have a way to automatically detect and react when it's time to update the lease. So let's do that. Let me check my notes. The quotient. I also want to know, for this example, quotient, that's the integer left over when you do that's the how many times the divisor goes into the, well, we're going to get into fractions here. If here's a fraction, that's a fraction. Excel helps so much. There's a trick. You can, if you precede the value in a cell with an apostrophe, Excel won't try to automatically figure out what you meant. So it won't convert I want 5/6. Probably Excel is trying to convert it into the 5th of June. So here, 5 is the numerator, 6 is the denominator, and when I divide the numerator by the denominator, any whole number is the quotient. Quotient. Oops. And then the remainder, that's what we got when we use the modulus. So this is actually the quotient function. Well, that didn't work out so good. And this is the modulus. It's mod function. Okay, so what we want to do is we want the quotient, and you'll see why. Quotient. I don't have to type it all over again. No, we're okay. Quotient is, again, we're dividing, this is just the count. This row 8 way up here is just the count of our months since beginning with the start date, the start month. And that's the numerator. The denominator is, once again, our term. Term 2. So you can see for the first year, it's going to be 0. It won't become 1 until we go into the second lease. So this is a way you can count which iteration of the lease are you on. First, second, third, and it's good to start with 0. I'll show you why in just a minute. So both of these, they're doing what we want them to do, so we can run them out to the end of our overall term. Super. Here we go. Excuse me. Okay, how you doing, Sam? Is that okay for you? It looks like you're the only one that's joining us today. So if you got any questions, just pop them up. If you've got a microphone, I think you can click a button that looks like a hand, and I can turn your microphone on if you just want to chat about this. Yeah, that's fine since it's just the two of us. Although you can see here, it says there's 2 people logged on. One of those is me. I set it up on my laptop so that I could verify that to me, it seems like the sound is working okay. Okay, so we've got the modulus, which is the remainder after we divide by the term, and that's how we figure out when the lease changes. And then we have the quotient. Did I not type that here? Yeah. Quotient, which tells you which iteration of the lease we're on. So now I'm going to I can just do this. I don't want to do that. I'm just going to clear that. And I'm going to push this down a little bit more. Okay, now we're going to do this again. And it's the monthly recurring cost. But now the monthly recurring cost, of course, it starts as we go way out here. It starts as MRC, which is here, and I'm going to do function F4 to make it absolute. So at this point, I think I'm just going to give you the formula. You'll have to decide for yourself if it's right, but because I took a little time to figure it out for myself. Okay, there's the formula. You can see here I'm going to explain it here, but I did build in something called the bandwidth discount. And this is my idea that for any lease period, the next iteration or the next instance of the lease should be a little cheaper. That's the advantage of having a short-term lease is you can accumulate all those future discounts. So for example, if it's $120 this month, if I sign the lease 12 months from now, maybe it's down to $115 for the exact same bandwidth. You understand what I mean? So I'm going to build in what did I call it? Lease discount? Rate of bandwidth cost decline. Yeah. And I think I said for 12 months, maybe it declines 5% a year. At a percentage. And I think that is, what did I call it? Bandwidth discount. This will be bandwidth discount 2. Okay. So let's look at this again. I'm using the power function, which is just the two arguments are, here, let's do it. Two arguments are the number, right? And then the power. So what I'm going to raise to a power is the discount. So what is the discount? It's 1 minus the bandwidth discount So if the discount is 5%, I'm going to multiply the starting MRC, the starting cost. I'm going to multiply that times this power function, 1 minus the bandwidth discount times the number, and the number is going to be the iteration. So this is the reason you start the quotient at 0, why that's correct, because for the first one, you want the product of this to be 1. Anything raised to the 0 power is 1. And if the quotient is quotient is what you're raising your discount to the power of, it's hard to say that correctly. You want the result to be 1, so you get your initial MRC. So again, the initial MRC was, oh, I didn't do that. I got to go find it here, and I want to make that, there we go. It's easier to see down here in the box. This is the starting monthly recurring cost, or the monthly recurring cost for this iteration of the lease. And I want to multiply that times this power function, which essentially tells me how much did I discount the starting, how much of a discount accumulates for each subsequent iteration of the lease. So in the first iteration of the lease, there is no discount, right? That'll only happen on the second and subsequent iterations. So let's bring this out, and I'm going to change it back to a 6-month term so you can see a couple of them right here on screen. And so you can see straight away with a 6-month term, my modulus changes here at the 6th month, 7th month actually, right? So that triggers my function. And my quotient also changes at the 7th month. And then down here in my MRC, this 120 was the starting monthly recurring cost, MRC, for the first lease we signed. And then when we sign a new lease, it's going to be 5% cheaper, and that's here, right? And then starting in the second iteration, or the 13th month, right? It goes down again. So now my model is doing pretty good. So you can see now how the MRC changes. If I change my rate, let's not do that yet. So I need to subtotal this, just like up here. Okay. Yeah. And then, but I got to change this. So I want to make sure that's correct. Yeah, this is okay, because I'm not going to include this up here. I want this one. This was our first go at it. And now we've modified it so that it takes into consideration these changing variables. This one up here essentially hard-coded one rate, whereas this one allows us to get a different rate over different lease agreements. So now we can extend that out. Oh, ran out of X's. We needed more X's. How we doing, Sam? Make sense to you? Are we doing okay? I know I'm going pretty fast. I'll try and recap this again next week. And again, I'll send you the workbook. I'll do that all by hand. There we go. Okay. Now, how do we know these are the same? If I just add this is just, 100 is 10 years in 1 month. Yeah, 10 years in 1 month. So at $100, it's easy to calculate. This one's more difficult. And either way, we need to take a different approach, because although in this very simple example, this very simple model, we didn't have a one-time cost. Many, probably most models will have a one-time cost. Do we have time to do that? Yeah, I'm going to just delete this because I don't want it to step on us. A one-time cost might be like maybe $100. Just a setup fee, the service provider, for setting up a cross connect or provisioning it in their systems or whatever, right? It's not unusual to have a one-time cost. So we're going to have that down here too. I didn't really plan to do this, so now I'm going off the reservation. So you can see that for the first month, see, it included it, which is what we want, of course, right? But technically, if it's a one-time cost when you sign the lease, out here at 6 months, I should have another one. Technically, right? Every time I sign the lease, I'm going to have this one-time cost. So for now, I'm just going to leave that out. How you do this, though, there's a technique that I'm going to show you now for calculating the cost of a long-term model like this. You can't just add up the numbers. There's a feature, if you ever talk to your finance people, it's called the, what would I say? Well, the cost of money, the basic premise is this: $1 today is worth more than $1 tomorrow. So if we spent, $100 in this first month, monthly recurring. Next month, yeah, we're paying $100, but from today, looking out 1 month, it's not really worth the same amount of money. And 8, 9, 10 years out, it's worth, it makes a difference. So the way you quantify that is, I'm going to give myself a row here. The way you quantify that is called net present value. And it's just the NPV function. And NPV is the rate, which is often called the cost of money, and then all the values you're summing. So effectively, that's all these terms. So I'm just going to say, let's say the cost of money is 6% a year. Let's do that. Let's make that a variable. And probably 6% a year is an okay amount. Do I already have a cost of money? I do. Okay, there's the cost of money. And our net present value function, NPV, is the cost of money and then all the terms, all the things we spent. So right there is that's the array of values. But this is not quite correct, because cost of money, this is a annual percent, 6%, and these are monthly increments. So the cost of money would be divided by 12. So the net present value of one-time long-term lease at $100 monthly recurring cost is $9,161. Okay, let's do the same thing down here for this one. I got to check and make sure that this is correct. H37, is that right? It is correct. H37 to DX. So this is correct. So you can see with a 6-month term and a 5% every 6 months declining cost. So probably we need to change this. So again, the rate of bandwidth cost decline, that's how much the value of it's the assumed discount, or the way we take into consideration how the cost of bandwidth declines over time. And probably a better model would say, well, whatever that is, if it's 5% a year, let's convert that 5% a year to be the correct amount for whatever the term is we're choosing, right? So if it's 5% a year and I'm doing a 6-month term, this stupid model, a very dumb model, is going to give me 2 5% discounts on, a 5% discount 6 months from the beginning and 6 months after that. Well, probably that's not right. That 5% discount, it's an annual discount. So probably we shouldn't stack it up like that. And I didn't anticipate that in my practice, so I don't want to wing that. What I think we should do, though, is this one-time cost. So it's okay up here. I'm just going to include that. Time cost. This is like a setup fee, one-time cost. And this would be I didn't use that, but I haven't used that in the previous one. So let's say the one-time fee is $100. So down here, I could put function F3. There's my setup fee right there. So there's my $100. Did I put it in the wrong place? Why did it jump way over there? Here we go. So there's my setup fee. And this should only be applied when I renew the lease. So the lease renews whenever my modulus is 0, right? That sounds like an if, right? Sorry, that's the net present value. If and normally you would do an expression here. If this is equal to 0, right? You'd probably do something like this. If B1 equals 0, do whatever, right? But the way the if function works, a number, any number not 0 is true. A 0 is false. So this is the way if works. Like this. That's basically an if function. Here's the expression. The if function tests the expression. If the expression is true, it does this argument. If the expression is false, it does this argument. So normally you would do something like this. What was that? Setup fee. I don't know. B1 equals 0. No. If it's yes. That's how it might work. But you can simplify that. I can just say B1. Because if B1 is 0, that's no. That's false directly. So if B1, if it's 0, this is the true condition, right? Which is what I want. So let's try that now. If the modulus is 0, apply. That means I'm renewing the lease, so apply the setup fee. So here we go. If H27, apply the setup fee. Otherwise, don't. And if did I get it backwards? H27 is 0. That's false. Yeah, so I did it like this. 0, comma. Sorry to confuse. So now it should. Yeah, only when I renew the lease does that charge occur. And if I change my lease term, maybe if I make it 8 months, see out here, this will change, right? Yeah, see it slid it. So if I'm back to a 12-month lease, and you see it shows up here, and it's changed my net present value. So let's run this all the way out. And you can see every 12 months it appears. Now our model is getting fairly good. I mean, I think it's actually getting fairly accurate because we've taken into consideration the MRC. We've taken into consideration the lease changes many times during the 10-year interval. We've taken into consideration that each subsequent renewal of the lease is at a slightly lower monthly recurring cost. And we've taken into consideration the setup fee, only one for the long term because there's only one lease. And every time the lease renews, we get a new setup fee in the short-term lease situation. So you can see now, even though you have this model, really you got to look at two things. Come up here and change your terms. Yeah, change your terms. So let's say we start out at 125 with a 12-month term. It's over $10,000 now. So with these conditions, the long-term lease at $100 is enough. Yeah, but if we go to like an 18-month term, does it get better? See, now you would play around with it to figure out, well, maybe this $100 one-time fee is distorting it, or maybe it's our cost of money. Yeah, but it's a model. You can play with all these values. You've designed the model so that you don't have to edit the model anymore to play with all these variables. You just change the variable and the model figures it out, and you read out the value. So the one thing we didn't do is, if it's a 5%, I should say that, annual rate of bandwidth cost decline, that's an annual rate, we should calculate the lease decline. What's the actual discount from iteration to iteration of the lease? How would we do that? You want to try and do that real quick? So if it's a 5% annual rate and the term is 18 months, so I tell you what, I'm old school. I still like a piece of paper, but we can do it here, I think. Back up here and say, so 5% is to annual. But annual is 12 months, right? So what's the percentage X if it's 18 months? So we want to solve for X. That means the applied value. So without seeing it, we should expect it to be, if it's 18 months, so we get that annual 5% discount for 1.5 years. So that should be a little higher, 7.5% maybe. So X equals 18. Yeah, so it's going to be X. It's going to be X equals 18 divided by 12 times 5%, right? So applied bandwidth discount is going to be estimated, equals our annual rate of bandwidth cost decline. This is what we estimate it to be, times the term divided by 12. Ooh. Term 2. I think in the formula I did, divided by 12 and then multiplied by. And that's a percentage. Bingo. And that's a formula, so let's highlight that purple, right? And so applied bandwidth discount, now it will reflect, accurately apply a discount based upon the term we chose. Does that make sense? Sam, you getting that? Applied bandwidth discount. And yeah, that helped. Because for an 18-month term, the old way I did it, they got a 5% discount every time the lease was renewed. When in reality, they should have been getting a bigger discount for a greater than 12-month lease term. So let's take one more look at that. Yeah. So now, using this one, if you think the rate is actually 6%, so it lowered the cost of. So now you can see all you want to do. So in fact, you could really simplify, if you believe your model, do this. Long-term NPV, short-term NPV, and this is at value. And this is this value. Highlight that. I should come back and change all these, but it doesn't matter. So now I can just change my values, and I can see right here short-term and if I set my format correctly, short-term is better. I can just turn this into a number. So short-term is worse right now. But, if the cost of money were 8%, doesn't make a big difference. I like that at 6. And the one-time cost, what if it's 200? So let's go back to 100. So I want, if this could go up, here you go. Now you can see with a 12-month term back to back, the short term is better. Now, this is the purpose of a model. The model is way over here to the right, right? Let's get back to this. Yeah, the model is way over here to the right, this part, but you don't need to look at that. We've got it down to its one number, which is really what a model, if your model is good, if you believe your model, if you accept the value of your model and that it's all proper, we're down to one number here. That's kind of hard to see, isn't it? That's not a great color. Let's go to this other green. There you go. So this is about the only thing you have to look at. Again, once you're confident your model works the way you intend it and that you think the model actually reflects reality, you're down to one number. You make your changes here and you can just read what's the better deal. So when you're talking to your vendors, your service providers, and they make proposals for bandwidth cost, you can just straight away see who's giving you the better deal, because they might not all give you the same one-time cost. They might not all give you the same monthly recurring rate. Yeah. But this is what modeling does, is you take a relatively complex situation and distill it down into a number. It just doesn't get any easier than that. Okay, so there's probably a couple of things we could do with this. One is I arbitrarily said that we're going to look at 10 years, but I could run this out farther to the right, more months, and then make it a variable. How many years does this run? How many years does this model run? Excel lets me go out, I forget how far it goes out. How many columns? Well, XF, so it's, I don't know, 32,000 columns. So I could go out hundreds of years if I wanted. All I got to do is fill everything out to the right, and then have to include my term, but that would be right here. These would total up everything, but I would only have to change my net present value calculation so that it would. That's the offset function. Do you remember the offset function? We've done that before. We use offset for dynamic named ranges. We also use offset for a rolling average. If you want to always be looking at like the trailing 7 days or 2 weeks or whatever, use the offset function, and it's really easy to do. So we do something like that, and one of the terms to the offset function would be, how many months are we looking at? Is it a 10 years? Is it a 120-month model? Or is it a 20-year, 240-month model? That would just be a variable here in the model, and plug it in. All right, Sam, any questions? Thanks for sticking around with me. I appreciate that. I hope it was helpful. Give me some questions. I'm going to turn off my screen here. Sam, you got any questions? Are you still there? That's the problem with a free webinar. It's easy to not pay attention. All right, well, that's it for today then. Thanks for joining me. Let's see. I'll post this. This is going to be on YouTube pretty quick, so you'll be able to find it right here. Mario, thanks a lot. That's the YouTube channel. And I'll send you an email here in just a second. Well, later today, I'll send you an email with a link to the YouTube channel, and you can download the workbook. All right, Mario, I keep saying Sam. I didn't see that you were here, Mario. But anyway, thanks for joining us. I hope you got some value out of this. If you have a model you're working on and you want some help, send it to me or send me an email, and we can talk about it a little bit and figure out how we can help you out. Thanks a lot, Mario. Have a great day. Bye-bye.